Welcome to Understand the Math. In this video, we're going to learn how to evaluate logarithms. I'll show you the formula that you can use, and then we'll walk through 6 examples together, step by step, so you'll know exactly what to do. Let's start with the formula that we're going to be using. This formula is based on the fact that every logarithm can be written in exponential form, and then every exponential can be written in logarithmic form. I put the formula up here in our green box, and this formula just tells us the 2 equivalent forms that we can write a logarithm in. If we set log base a of x equal to y, then a raised to the y is going to equal x. This formula on the right-hand side is the one that we're going to use when we evaluate logs. Let me walk you through really quick how this works. When we have to evaluate log base a of x, we're going to set it equal to the variable y. If you exponentiate each side of this equation, you'll see that a log base a cancels each other out, and what you get on the left-hand side is just x, and then on the right-hand side, you have a to the y. When we set our logarithm equal to y, we then can find out what this log equals by solving the equation x is equal to a to the y for y. When you evaluate logs, it's really good to remember that log base a of x is just an exponent, that base a must be raised to get x. Let's now walk through all of our examples so you can see exactly how this works. When you evaluate a logarithm, what you want to do is write down that logarithm. In our case, we have log₂ of 4, and we're going to set it equal to y. That's your starting point. What you're going to do then is switch to the exponential form, which is 2 to the y is equal to 4. And that's the equation that you're going to solve. We're trying to find what y equals. So you just have to ask yourself, to what power do I need to raise 2 to get 4? And that power, which is y, is going to be equal to 2. So that tells us that log₂ of 4 is equal to 2. Let's now look at our second example. Just like we did for our first example, let's write down our log base 10 of 1,000, and set it equal to y. Now we're going to go to the exponential form, which is 10 to the y is equal to 1,000. And then we have to figure out what y should be in order to get 1,000 on the right-hand side. If y is 2, we would get 100, but if y is 3, we're going to get 1,000. So our answer is going to be y is equal to 3, which means that log base 10 of 1,000 is equal to 3. Now let's look at our next example. This one is different because we have a fraction in it. We're going to solve it just the same way. We'll write down log base 3 of 1 over 9 is equal to y. Then we'll change this to our exponential form, which is 3 to the y is equal to 1 over 9. And now we have to think a little bit about what to do. Notice that the 3 and the 1 over 9 are different numbers. So our strategy is going to be to write our right-hand side 1 over 9 in terms of 3. 9 is equal to 3 squared, so we can write this as 1 over 3 squared. But we don't want to have a 1 over 3, we want a 3, so we're going to invert this fraction and write it as 3 to the minus 2. Now all we have to do is just equate our powers, and we can see that our y is equal to minus 2, so that tells us that log base 3 of 1 over 9 is equal to minus 2. Let's look at 3 more examples that are a little bit more difficult than these. To solve our fourth example, we're going to start by writing down log base 4 of 2 is equal to y. And now you're probably getting used to this. What we're going to do is convert to the exponential form. So we have 4 to the y is equal to 2. And now we can think about what y should be in order to get 2. Because 4 is bigger than 2, we know that y is going to have to be a fraction. So we want to think, what fraction can we raise 4 to in order to get 2? And it turns out that if we take the square root of 4, we're going to get 2. So y is going to be 1/2. And we can write down our answer as log 4 of 2 is equal to 1/2. Before we go on, let me show you another way to think about this. Instead of just writing down y is equal to 1/2, we could have changed 4 to be a power of 2. So we could have written 4 as 2 squared to the y is equal to 2. And then this would have given us 2 to the 2y is 2 to the first power. And then 2y is equal to 1, which gives us y is 1/2. I think it's harder that way, but I think it's good to see that because in our next example, we're going to have to use a strategy similar to that. Let's now look at example 5. We'll start by writing down that log base 9 of 27 is equal to y. And now we can put it in its exponential form. So we have 9 to the y is equal to 27. There is no easy answer to this. If y were 2, we would get 81, but we want 27 on the right-hand side instead. What we have to do for problems like this is we have to get both 9 and 27 written in terms of the same number. 9 and 27 can be written as powers of 3, so that's what we're going to do. We're going to write 9 as 3 squared raised to the y, and then 27 is 3 cubed. So this is 3 to the 2y is equal to 3 cubed. We can then set our powers equal to each other. 2y is equal to 3, and that gives us y is equal to 3/2. Our answer is then log base 9 of 27 is equal to 3/2. This is our last problem, and I put this on here so that you can maybe pause the video and see if you can complete this on your own. I bet you can. I'm going to start by setting log base 8 of 16 equal to y. And then we can write this as 8 to the y is equal to 16. Now we're going to do something similar to what we did in problem number 5. We're going to write 8 and 16 in terms of the same number. 8 is 2 cubed raised to the y, and then 16 is 2 to the 4th. So on the left, we have 2 to the 3y, and on the right, we have 2 to the 4th. And then we can set 3y equal to 4. We're just equating the exponents, and that gives us that y is equal to 4/3. So we can conclude that log base 8 of 16 is equal to 4/3. And that's it. I hope that you now feel more confident solving logarithms. They really aren't as hard as they seem at first.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.